Welcome to another video from explainingcomputers.com. This time I'm going to take a look at the Asus Tinkerboard, which is the first single-board computer to be launched by a mainstream computer manufacturer. The Tinkerboard has also been described, at least in some quarters, as a Raspberry Pi killer, which is a pretty bold claim, so let's go and take a closer look. So, here's the Tinkerboard in its white and purple box, and it's interesting to see a single-board computer in a more traditional manufacturer's box. And if we flick it over, you will see on the back we have icons to tell us a bit about the thing. You can see that it's got a quad-core 1.8 GHz processor, 2 GB of RAM there, and it's also got 4K hardware decoding. Indeed, it's even apparently compatible with jigsaws. Don't quite know what that means, but I'll look at all the technical specs, of course, a bit later on. But for now, let's flick it over and get inside the box, of course. That's what you want to see. And, there we are. There is the Tinkerboard. Let's get the thing out. Come on. Come on. There we are. I thought it was caught there. And anything else in here? I doubt. We have in the box a heatsink. That's a bit unusual for a single-board computer. That's a sign of things to come, I think, elsewhere as well. And there's also here, a manual, an instruction leaflet with all sorts of exciting information all about our Tinkerboard. That's very nice. I'm sure we'll read that in depth a little bit later on. But of course, the thing you really want to see is the Tinkerboard itself. Here it is. And we'll just get it out of its little bag. And, Mr. Scissors are waiting to cut something, and nothing needs cutting because the bag's just something that's folded over so we can get straight in. Rustle, rustle, rustle. And here we have the Asus Tinkerboard, which is very, very Raspberry Pi-like, isn't it? As I'm sure you'll agree. And to show you quite how Raspberry Pi-like it is, let's bring in a Raspberry Pi 3. And putting those two together, you can see straight away these are very similar computers. The form factor is pretty much identical. At the end, we've got the same position for the connectors, USB ports and Ethernet. We've got full-size HDMI in the same place, 3.5mm jack in the same place, display and camera connectors in the same place, and 40-pin GPIO connectors in the same place, although a little bit more colourful here on the Tinkerboard. So the form factor is pretty much identical. They've even got the mounting holes in the same position. And if you're thinking to yourself, does this mean therefore you can take a Tinkerboard and put it in a Raspberry Pi case? Well, apparently you can. Asus claim this will fit in most Raspberry Pi cases, and clearly that's very handy. Now, of course, the technical specs on the boards differ. The Asus is a more powerful board, as we'll see in a second, and that means it's also got a higher price. So if you're wondering what the price differential is, it's now, February 2017, and in February 2017, a Raspberry Pi will cost you about $40 in the United States, or about £32 in the United Kingdom. In contrast, a Tinkerboard, I bought this one for £55, including VAT, including sales taxes. That's about £45 plus sales taxes, but at £55, that's about $69. So the Tinkerboard is about 70% more expensive than the Raspberry Pi 3. And so the next question to ask, of course, is do you actually get that much more for that extra investment? Right, now let's delve into the Tinkerboard's technical specs, and we'll start with this, which is its system on a chip, which is a Rockchip RK3288. And this includes a quad-core ARM Cortex-A17 CPU running at 1.8 GHz. And that compares to a Raspberry Pi 3, which has got a ARM Cortex-A53 CPU running at up to 1.2 GHz. There's also, as you would expect on a system on a chip, a GPU here, and the GPU on the Tinkerboard is an ARM Mali T760 running at up to 600 MHz, and that compares to the Video Core 4 GPU on a Raspberry Pi 3 at up to 400 MHz. So you've got a more powerful processor and GPU on here, the Tinkerboard. And it's worth noting the Tinkerboard supports up to 4K video. It should, over its HDMI 1.4 output, be able to output 3840 by 2160. And it's got onboard hardware decoding of H.264 and H.265 video. If we flick the board over, we can see the RAM is on the back of the board. There's the two RAM chips, and we've got 2 GB here of DDR3 memory, and that compares to 1 GB of DDR2 memory on a Raspberry Pi. We flick the board back again. We have got a Wi-Fi and Bluetooth module. There it is looking close up. And you can see the antenna has got a little cable there which you can disconnect. So as you can, as is described in the manual from Asus, you can upgrade it. You can connect it to a better external antenna or a longer antenna, something you can't do on a Raspberry Pi. So you should get better wireless performance from a Tinkerboard than a Raspberry Pi, at least in theory. You can also see in terms of hardware here, we have got a camera connector and a display connector on the board, exactly the same as you got on the Pi. And the display connector here will take Raspberry Pi displays. So there's things like the 7-inch Raspberry Pi display could plug in here. And this means we've got pre-available displays to use with a Tinkerboard, but it also means if Asus launch peripherals with a Tinkerboard, they should work with a Pi. So that's good for everybody, I think. We turn the thing around. On this side, we have got our HDMI connector. As I mentioned, HDMI 1.4 as far as I can find. Some reviews are saying HDMI 2, but certainly the documentation from Asus says this is HDMI 1.4. And next to that over here, as you would expect, we've got a micro USB connector for connecting 5-volt power. Next to that, we've also got a 3.5mm jack, and this is for audio only. There's no composite video from this board, but the audio here is stereo audio at 192 kilohertz, 24-bit audio. So you should be able to get very good quality audio out of this. You certainly can't get good quality audio out of the jack on a Raspberry Pi. And it's also worth noting here that because we haven't got composite video out on this jack, it is a TRRS jack, so the extra sleeve is used for a mic input. So you've got mic input and a good quality audio output there. If we turn to the end of the board, you can see we've got 4 USB connectors, sadly all USB 2, but at least we've got 4 full-size connectors. And next to that, we've got our wired network connection. We've got a 1 gigabit Ethernet socket. Yes, we've finally got free of having just 100 megabit Ethernet like on the Raspberry Pi. We've got 1 gigabit. And you'll be pleased to hear that this is not sharing its bandwidth with the USB controller. We've really got fantastic wired connectivity here on the Tinkerboard. Although you might notice, just to be slightly different, it's upside down, or at least the socket's the other way up to the one you'd see on a Raspberry Pi. Also, in terms of connectivity, you can't fail to have noticed we've got these fantastic GPIO connectors, 40 GPIO pins, just as you have on a Raspberry Pi. But as you can see, they're color-coded. Never again will you wonder if you've plugged in your ground connector to the right connector, your 5-volt or your 3.3 volt connectors to the right pins, because you can see they're in their nice red and black and yellow and green colours. Very simple but very effective innovation there. I should have mentioned before, we have of course a micro SD card slot on this. You'd expect that. It's on the back of the machine. There's no onboard flash memory on this machine, but we do have our micro SD card slot there, which is a UHS 1 rated slot. So that's pretty good as well. So there we are. That's the Tinkerboard, a nice piece of hardware. And I would just note that it feels really nice. It's a little bit heavier than a Raspberry Pi. It just has a little bit of quality to it. The way the board is printed, you could probably see all the little labels are on the board. It's just a nice thing to handle, a nice single board computer. And in theory, given the hardware it has, at least according to Asus, it's twice as powerful as a Raspberry Pi 3. And so I think it's now high time to go and download an operating system image, put it on a micro SD card, put it in our Tinkerboard, and to put this thing through its paces. Right, as you can see, I've now got the Tinkerboard all connected up, all raring to go. And to start off, to get to this position, I went to the support section of the Asus website, and I'll include a link to the page in the video description. And on this page, under Driver and Tools, I selected Others, and then I expanded things up and downloaded the TinkerOS Debian file. And in the standard single board computer fashion, I used a free SD card formatter to format my micro SD card, and I wrote the Debian image to it using Win32 Disk Imager, and then of course put the card into the Tinkerboard. As you probably noticed, I've also removed the backing from the heatsink which came in the box with the Tinkerboard, and I fitted the heatsink on top of the Rockchip RK3288. And in case you're wondering, you really have to fit the heatsink on the Tinkerboard. They advise you that in the manual. You'll get burnt on the chip if you don't. And I think that's true. It does get very warm if you don't fit the heatsink on top of the system on the chip. Anyway, things are clearly all ready to go here. So I'll turn on the power. If I can get to the switch somewhere around here. And there we are. Switch is on. And you can hopefully see we've got a little tiny red LED there. And if we now look to the screen, you'll see the screen is completely black. Nothing at all comes up on the screen when you boot your Tinkerboard, which I find extremely disconcerting. It's one of the only single board computers I've ever bought when I've connected the thing up, first booted it, which is not the first boot, and gone, oh, it doesn't work, can't be working because nothing's on the screen. But the first thing you see that's anything working is when it actually arrives, as it has just done there, when you actually see something on the screen, and we've arrived in Debian on the Tinkerboard. And this is what you get, as you can see, with this interesting blue pattern. And for some reason down here, the thing does not like to accept the fact there's no wired connection here. If I don't disconnect that, it sits there being upset forever. I've got my working Wi-Fi connection, that's absolutely fine. You'll see basically it's a fairly minimal installation, which in many ways is a good thing. It's not wasting space on our micro SD card. We go down to the menu, you'll see there's not a lot installed. Accessories, there's really not a lot there, is there? Calculator, imager, etc. That I've installed on this GIMP, which I'll be using in a second in a test. Internet-wise, we've got the Chromium web browser, sound and video. I've added VLC media player, but other than that, that's what you have. System tools, terminal basically, and a file manager, and there are various preferences and settings which obviously you can work on. But basically, they let you put onto this machine what you want to put on yourself. We'll just launch the web browser, which you can also do from down there. So we'll just bring up Chrome, just to show you that Chrome comes up fairly fast. That's not bad for a single board computer. And assuming the world is with me, if I just click on that, hopefully we can show we can get to a load of paging pretty fast. This is a fairly responsive web browser on the system. Other than that, there's not a lot to say here really, because as I said, there's not a lot instantly installed. It feels quite a responsive system. The thing works, nicely, but there's not a lot to write home about here. This is basically a working version of a Debian running on our Tinkerboard and working quite nicely. I will, of course, do some tests of this, particularly looking at the video facilities and how it might play media. But I'm not going to do that today, not least I haven't got any facilities here for running 4K stuff, and really we want to be testing it out up to 4K to see really if it's worth doing that. So I'm going to wait till I've got Kodi and media players on the machine, and then in a future video I'll check out the video capabilities. Right, I told you I installed GIMP for a reason, and I want to do a test comparing the speed of the Tinkerboard with a Raspberry Pi 3 applying a filter in GIMP, a test I've run several times before. So I'm going to go to Filters. I'm going to then select Edge Detect and Neon, which is quite a complex filter, gives us a good test of processing power. I will zoom things down, we can see things together, press the button at the same time, there they go, and unfortunately we can't see the progress indicator on the Tinkerboard. It seems to be off the screen somewhere, but hopefully it'll beat the Raspberry Pi. It's going to be very, very close. And the Tinkerboard, yes, it has won 10.1 seconds to apply that filter to the 3000 by 2000 pixel image, but it's not a massive win, is it? It's not a double the performance as we've been led to believe by Asus in terms of Tinkerboard versus Raspberry Pi 3. Now, of course, that's just one test, but it is a good test of processor power. I did expect the Tinkerboard to do better there with its faster processor and more RAM available. So there we are. The Tinkerboard, it's a nice machine. It's yet to prove itself, at least in my eyes, to be that much more powerful in practical use than a Raspberry Pi 3. It's great to see a mainstream manufacturer like Asus entering the single board computing marketplace, and their first offering, the Tinkerboard, does seem to be a very decent piece of kit. As we've seen, it runs the Debian Linux operating system very well, and I'm sure it'll also make a great media player. And indeed, in a future video, I'll be installing Kodi on the Tinkerboard, and we'll see how that works out. This all said, we do need to remember they've called it the Tinkerboard. They do expect us to tinker with the thing, to do projects, to get things connected up to those GPIO pins, to do all those things we do with the Raspberry Pi on the Tinkerboard. It has, after all, been called in some places a Raspberry Pi killer. And in that respect, we do need to remember that a single board computer will rise or fall, live or die, on the basis, yes, of its hardware, but also its support. And right now, there isn't a lot of support for the Tinkerboard. Indeed, when they launched it, Asus didn't even launch a dedicated Tinkerboard website. And right now in February 2017, there still isn't a dedicated Tinkerboard website to go and do things like downloading its operating system images, etc. And without that support, I think it's unlikely it'll really take on the Raspberry Pi and be fully adopted and embraced by the single board computing community. But we shall see what happens. Anyway,